Alright, welcome everybody. This is my first video recording sort of showing off this new software that I've been working on for the past about 2 months. And also it's going to be sort of a video tutorial showing you how to use the basic interface. So what this is Think. And Think is a visual programming language. So what that means is traditionally if you wanted to make any sort of application for your computer, if you wanted to make a web browser or an email client to check your email, or a video game, something like that, you have to program all of that sort of line by line by just writing out computer code in some semantic language, and then the computer is going to compile that and interpret it all and sort of know what to do. So semantic programming, kind of programming by lines of text the traditional way, is very powerful, but it kind of has some drawbacks. It can be very intimidating to learn just because there's so many new terms, new words. It's almost like learning a foreign language. Also, it's prone to syntax mistakes. It's possible to make invalid syntax. You can make a typo somewhere in your file, and then your whole program might not compile and run because it has this typo in it. So you can sink a lot of time into fixing things like that. And also kind of the biggest issue for me, and really what pushed me to start developing Think, is that whenever you're doing semantic programming, whenever you're programming text, you sort of have to think in your head. For every line you're writing, for every character you're writing, you have to think how the computer is going to interpret that. You basically have to emulate a computer in your head and think, how is that computer going to interpret that line of text? And what's it going to do? And you sort of have to have running all the time in your head this sort of virtual computer in a sense to think about what you're doing. So my idea with Think is, what if you can make a way of programming where the programming itself, the thing you're manipulating itself, shows you what it does. You don't have to do any of this emulating, or at least not as much. So the idea with Think, it's a visual programming language, so instead of programming computer applications by writing lines of text, you program them by drawing these graphs that kind of look like these little flowcharts that connect together different functions. So I guess just to show basically how it works, I'll write sort of the hello world program for this. Just output a simple line of text to the screen. So what I'm going to do, you can see here I've got this start kind of diamond here. And this is the entry point, essentially. It's where every graph starts. When the computer first starts executing your graph, it'll start here. So if I want to call a function, so to speak, if I want to do anything, I can just click here on the bottom half of this and drag away this little white wire, and it'll follow my mouse around. I can just drop it wherever I want, and I'll get this contextual menu. And this kind of shows, of all the functions that Think has available to it in its default library, it dynamically calculates which ones would be appropriate in this situation, and it lets me pick one. So for example, if I want to just output a simple string to the console, I'll pick log to console. That's the equivalent of sort of the print or print line, printf functions in a lot of traditional languages. So you can kind of start to see how this works. All functions in Think are represented as these sort of boxes. We've got the name of the function, but other than that, they're sort of a black box. You don't really see the internal workings, although you can edit them, and I'll get to that probably in a later video. You can edit the internal workings of a function and make your own custom functions. But in terms of how they're represented in the graph, they're just sort of these black box functions. They take a bunch of inputs and outputs and outputs. So on the top here, we've got a bunch of nodes. These all correspond to inputs. These are the input nodes. Then I've got output nodes at the bottom. And so then you build graphs by just connecting input nodes to output nodes. It's always input to output or output to input. You would never connect like one input to another input. But that'll make more sense as I go along. So if I were to execute this graph now, you can kind of see how it would start to work. The computer is going to start here. It's going to follow this wire down. It's going to execute this log to console function. But if I were to run it right now, it wouldn't work because I've got one other node here that doesn't have anything going into it. If the log to console function needs a string, it needs something to log. So it has this green node here. Green, and think different colors represent different kinds of data. So this white wire and these black nodes represent no data. There's no data going through here other than just an impulse that says do this thing next. But in order to do this, I need to actually have some data to output. So what I can do, I can just drag this green node up. Think green represents strings, which are like text data, series of characters, so a word or a sentence or something. Just like before, I can drop this up here, and there are a lot more options in this this list because there are a lot of things that can be represented as strings. But I'll just choose the first one, constant string, and this is the equivalent of a final in Java, or just a literal argument. It's basically, it's not a variable that's going to have changing information. It's just a plain piece of data that we're putting right into this function. So, and I can type anything I want here. For example, hello world. And now that's it. Now this is a working function. So if I want to see how it executes, I can go up here to run, and I'm going to hit debug so that you can kind of see it step through. Now the first thing it does is it brings up this little console, but you can't see it in the recording, so I'll just dock it down here to the bottom of this window. Oh, it says error. Disregard that. That's just something I was doing when I was testing out making this console dockable. But so what it'll do is, you can see first I've got the start node highlighted, or the start little box here. So that's what it's going to do first, and then if I press tab, you can see it'll sort of follow the string down. Now the log to console is highlighted yellow. That means that's basically what's executing. But you can see if I click here, if I click on this little node, it'll say it's undefined. That means there's no data coming into this node. And log to console needs some data to execute. It needs to know what it's printing. So it's going to just follow this wire up looking for some data. So it's going to move up here, and then if I press tab again, it'll execute that. Now you can see coming out of this node is the string hello world. And so going into this function, I'll get the same string. So now if I press tab one more time, it finishes, it executes, and it prints hello world to the bottom. So that's the basic sort of syntax idea for how think programs are built. If I want to run it just as one program rather than stepping through it in debug mode, I can just go run, and it'll run all at once. So just to give you a little bit of a better idea of what this language is capable of, I'm going to write a little demo program here